What will be the value of thermal conductivity of a composite rod given in the question? Whereas the composite rod was produced by joining two rods of different materials, and the thermal conductivity of each rod is given as K1 and K2. And in the diagram, they represent the temperature on left side as T1 and right side T2. So we can say the temperature difference here is T1 minus T2. And D is representing the length of a material. Both rods are having a same distance value, or as we can say they are having a same length D. So here, whenever there is a heat is applying on one side, it will come out of the next end, and we can say the amount of heat which is given on one side will equally distributed to each sides. So here we can say it will be H1 and H2. So we can write the total H, the heat we gave, will be equal to H1 plus H2. It's known that the formula for H, the heat, is nothing but Ka T theta divided by Tx. Whereas K is representing the thermal conductivity, A is representing the area, d theta is representing the change in a temperature, dx is representing the length. So now we can apply this for our question. So here we can say the total area is A. So for a half, for a rod A, we can say it will be A over 2, and rod B, it will be A over 2. So here we can write K A times T1 minus T2 divided by N will be equal to K1 A over 2 times T1 minus T2 divided by N plus K2 A over 2 T1 minus T2 divided by N. So here we can simplify the similar terms. All the A's will cancel each other, and the temperature difference as well, and the length as well. So when we are checking the remaining term, we will have K is equal K1 divided by 2 plus K2 divided by 2. So here we can write the total thermal conductivity of a composite rod will be equal to K1 plus K2 divided by 2. So the correct answer here will be option D.